is an introduction to area. I have 3 practice questions that I did in class or didn't do in class or ran out of time. Here are the ones I'm going to go over with you today. I'm going to read it because it's not very clear for some reason in this slide. The drawing below shows the end of the building that is to be bricked. If the area of the side of the building, if the area of the side of a brick, one brick is 1/10 of a square foot, find the number of bricks needed to completely cover this side of the building. The minute you see anything about area, you should know what that means in terms of the big picture concept. Area is essentially covering everything inside the boundaries that you're given. In this diagram, I see actually one rectangle and one large triangle. You might see one rectangle and 2 small triangles. That's perfectly okay. But the bottom line is, no matter how you do it, you've got to divide your diagram into sections that you can find the area of to be able to ultimately answer the question about the bricks. So the first thing I'm going to do is I'm going to investigate my formula sheet in case I've forgotten from a previous life how to find the area of a rectangle. I'll call the blue area number 1. So the area of figure 1 is found by taking the length times the width. The length of the triangle is usually the rectangle, the longest side, so 14 plus 14 be 28 feet. Multiply that by the width, which is 9. 28 by 9 is going to give you 252 square feet for the bottom half of the house, of the building. Now the area of the top, whether you do it as 2 individual triangles or 1 large triangle and add them together, it doesn't matter. But you do need to know the formula for the area of a triangle, which is the base of the triangle times the height of the triangle divided by 2. If I do the big triangle, it would be the base, the long base, which would be 28, because it's 14 plus 14, times the height of 4, and the formula says divided by 2. So 28 times 4 divided by 2, it's going to give you 56. Now you could have done half, 14 times 4 divided by 2, and got a 28, and a 28 add them together. You're still going to get 56 square feet for the total of the triangle. Now the area for everything, 1 plus 2, is going to be the grand of 252 and 56, which is 308 square feet. Now, the most important part of being successful in this stage of the game with these questions is, did you answer the question? And the answer is no, I didn't answer the question. All I did was find the area, but I want to know the number of bricks. So I have a relationship that says 1 brick covers 1/10 of a square foot. If I want to write that as a proportion, I can do it because it keeps my brain organized. 1 brick is the equivalent of 0.1, or 1/10 if you prefer decimals, 1/10 of a square foot. So then I want to know how many bricks, which is my question mark or my unknown, if in fact I've got 308 square feet to cover. So to solve a proportion, like usual, you have to cross multiply and divide by the unknown across from the unknown. So 308 times 1 is 308. Divided by 0.1 is actually going to give you a bigger number, which you would expect, because 1 brick does not cover a whole square foot. You need 10 bricks to cover a square foot. So 308 divided by 0.1 is going to give you 3,080. Now the answer is not square feet. The answer is 3,080 bricks. And that would be what you would highlight on your page as your selection. Question 5 on the examples says, determine the area of a shaded region of the figure. Around the final answer, the nearest 10th of A, that should say nearest 10th of a square foot, not just a foot. Area is always in square units. So area, you say to yourself, what kind of formulas do I have for area? In this case, the shapes are the circles. Start off, if you knew nothing, by writing down the area of a circle is equal to pi times the radius squared. Order of operations, you have to square your radius first. Now, the second thing in this kind of question, it's going to come up as a pattern, is the area of a shaded figure is typically not something that you can always divide up into pieces that you can find the area. You can't divide this up into rectangles or triangles. You're not left with a lot of alternatives. But what you really have here is a situation where you can find the area of the entire large circle, including the center. And then you can find the area of the center, which I'll color in pink. Then you could subtract them to find the area of just the green. So whenever you are going to have a shaded in between kind of questions, you should think about that as your strategy. I should find the area of the whole thing minus the area of the inside, and then subtract to find the area in between. The area of the whole giant circle requires you to know the radius of the whole giant circle. Well, the diameter is 12. The radius is going to be 6. So pi times 6 squared would give you the area of the whole thing, green and pink together. 6 squared is 36, times 3.14 works out to be, use your calculator, double check, use the pi button, 0.0973. We only have to go the nearest tenth. That's pretty decent for extra digits. The area of the inside pink circle, with a diameter of 6 and a radius of 3, I would do pi times 3 squared. So 3 times 3 is 9 times pi is going to give you an area of 28.27433. Now the area in between, the area of the shaded, would be the difference. So 113.0973. Take that, subtract 0.2743, and you're going to get an answer, calculator-wise, of 84.8296. You go back and reread, say, what was the question asked me for? They shaded each region. So you've got that nearest tenths of a square foot, so your final answer would have to be 84.8, because the 2 doesn't round the 8 up, and then your unit would be square feet. And that's the area of the green. Okay, this is the area of the pink. The 28 is the area of the pink. And the area of the green and the pink was the 113. Subtract them, you find the difference. This last question is quite tricky and will require some patience. Part A says find the perimeter. When you're trying to find the perimeter, you need to know what your dimensions on the outside are. You have to find this plus the big curved edge plus this plus the inside. These curved edges, of course, follow the pattern of a circle. So the first job here is to find the straight edge. From the center to the bottom, center to the outside, no matter where it is 15. From the center to the inside edge is 10. The difference would have to be 5. That's the distance on the straight edge along the bottom, and the top, same thing. The outside radius of 15 minus the inside radius of 10 would give you a difference of 5. Now, to find the curved edges that are yellow, we are going to have to find the diameter of the whole circle to find the circumference. So, in your mind, you should know that the diameter is double the radius.
Therefore, the circumference of the large circle is going to be pi times double 15, 30. But of course, you then have to divide it by 2, because you're only dealing with a semicircle. So pi times 33.14 times 30 divided by 2 gives you 47.123,889. Damn. Sorry for the mess. The circumference of the inside semicircle is going to be pi times the diameter of the inside circle. If you need to see it, you can sketch it out. But if the radius is 10, it's pretty clear, well, it's not from that the diameter would be 20. Double.
But then, of course, you must divide it by 2 because you want the semicircle. So pi times 20, 3.14 times 20 divided by 2. If you have your calculator, you're going to get 31.415926. I'm keeping, because I'm required to round the nearest thousands, I've got several extra places here. Now the perimeter, I want to go around the outside edge. I've got to add the 2 semicircles plus the 5 and the 5 to get the grand total. If you're walking around the shape, the C pattern, you've got to also add up the ends. That works out to be 88.53981 when you do all the bits. And then we're going to round. The perimeter is going to equal to the nearest thousands. The 8 would round it up to 88.540. Not 39, but 40 centimeters. That's the perimeter. To find the area, you have to then think about, I want the area between 2 lines. I want essentially, this time, the green space. So if you find the area of the entire large circle, and then subtract the area of the pink circle that you can calculate, you could subtract them to find the green. So let's start with the formula. The area of a circle is pi times the radius squared. Now we have only semicircles, so to do the math, you're going to take pi. The big circle is 15 centimeters. You're going to square it, but then you're going to divide it by 2 when you're done. So 15 squared is 225, times 3.14 is like 706, but then you got to divide it by 2. So the area of the half circle, the green and the pink together, is 353.42917. Now the area of the pink, which you don't really care about, but we've got to find it. Pi times the radius squared. So the radius of the inside circle is 10, but of course that's the whole circle. A semi is half of that. So you're going to get 10 squared is 100 times 3.14, so 314.159, and then divide it by 2, you're going to get 196.34953. Merciful God. Okay, now, the area of the green is going to be the area of the shaded in the middle. So 353 minus the 196 is going to give you 196.34953. What am I doing? I screwed that up. Just a second.
I gave the answer when I shouldn't have. I should be using the calculator and doing it live. That was the area of the answer, the area of the small circle is in fact a half of 314, which is 157.0796. Long and the short of it, 196.34953 is the difference. You round the nearest thousands. 349 plus 1 is going to become 350. So 196.350 centimeters squared. And that's the area of the green between the two semicircles.
So those questions that I've chosen to do in this video are difficult. They're kind of what I would call some of the worst case scenarios. Therefore, it wouldn't be a bad idea for you not to panic at this stage. Go to your booklet, read the examples, follow along. There are 6 practice questions at the end. Try those. The answers are done at the back of the booklet, and also they're done fully in a video, 2 videos, actually 3 video solutions. You can watch them if you want, pick and choose. The video that explains the question that you can't answer on your own. And if you need to, you can come get me for help later. Good luck. Thank you.